All right, so today, ladies and gentlemen, we're going to do 5 for day 2 notes. Yesterday, we talked about changing exponential expressions to logarithmic. We're going to kind of focus in on that again today. And then we graphed and evaluated those yesterday. So we're done talking pretty much about that. And then goal number 3, we're going to solve these things. Guys, I have 6 examples we're going to walk you through how to do. And then it'll be time to go. Before we move on, though, I don't know in this class or not if we talked about common logs and natural logs. I just want to refresh our memory on those. If we didn't see this, this will be new for you. If not, common logs and natural logs are two of the most famous logs, all right? So those are 2 logs that we should know. The first one's called a common log. This is, again, one of the logs we commonly use. So us math guys, we like to write things shorthand. So instead of writing 1x, we just write x, right? Well, if I write a log of 4, if I don't see a number right there for the base, then I need to know that the base is 10, okay? So if we run into example 11, something like this, I've got y equals 2 minus 3 log of x. There's no number there. Well, I should know, again, that base value is a 10. So A would be 10 there. That's called a common log. Okay? And then the other one that's special is called a natural log. All right, natural logs are denoted as ln. Why it's not nl, I really don't know. Other than if you put the L here, it might look like 14 and might confuse people, so they do ln instead. So ln is the natural log of 4. And anytime you see ln, guys, you got to know the base is e, the number e. So in this case, if I see ln, I know my base is e. And what's e? E 2.718. Okay, so we should know our base is e. Now, sometimes you guys forget that, and that's why I always like to refer back to the calculator. Okay, if you look next to 7 and 4, kind of kitty corner to the 7 is the common log, log. Okay, and if you look at second log, if you look above it, you'll see the exponential has a base of 10. So this log and this base are the same. So common log has a base of 10. And then the same thing you can see next to the 4 is ln. That's the natural log. And if you look above it, if you press second natural log, that's e to the x power. Okay, so these bases are the same. Okay, so if you forget, look back at your calculator, look at the exponential above it. That's the base of those 2 logs. Okay, so sometimes people forget that, but it's right there on your calculator. It will tell you. All right, so let's dive into our notes here. Just wanted to make sure we touched on that. So here we go, guys. We're doing a little conversion. So we have exponential. We have y equals a to the x. Then we know it's x equals log of y to the a. And we know we can do this because they're inverses of each other. The x's and y's are switching spots. Okay? So I always remember if I have an exponential, I have a base, I have that little exponent, and then that's usually equal to a number. So then we should be able to convert to a log. The base of the exponential is going to be our base of our log. That number is now going to go inside, and I'm going to have that equal to my exponent. And vice versa, if I have a logarithmic, I should be able to convert it to exponential. Okay? So as I start with example 1, it says solve each logarithmic expression or exponential equation. I have the log of 125 base n, and that equals 3. So I have the log, I got my base, I got my number, and that's equal to the exponent. So if it's logarithmic and I want to solve for this n here, I'm going to go ahead and convert it to exponential form. Okay? So I'm going to go do my base. My base of the log is the base of the exponential. So I have n. Exponent equals exponent. This is my exponent. So I have n to the third, and then equals the number, which is 125. All right. So I got n cubed equals 125. We need to solve for n, and this is where we cube root both sides. So we'll go ahead and cube root 125, and we should get 5. Okay. Just a reminder where that's in the calculator, guys. Okay. If I go to the math menu, let me clear all this stuff out so it's not so confusing. So if I go to the math menu, it's either example 4 or number 4, or you could do number 5. If you have a TID3 and you're doing number 5, I think you have to press 3 first and then go to the math menu. So if I want to do that, number 4, 1, 2, 5, press center, there you go. Okay. If you're using like the 4th root, you got to type in 4 there and then 1, 2, 5. And there you go. Okay, but we're doing the 3rd root, so we get 5. Okay, so this is an example where you have a logarithmic equation and the variable is in the base. Okay, convert, and then you're going to probably have to cube root or 4th root or what have you. So when you're doing number 2, I've got the log of 64 base 2 is equal to x plus 3. So now I'm giving you an example where your variable is on the exponent. Okay, so my base of the log is the base of the exponential 2 equals exponent. This is my exponent, and that equals the number 64. Okay, so I have 2 to the x plus 3 power equals 64. Now, from chapter 5.3, we talked about how to solve an exponential like this. You guys have ideas? How can I solve this guy now? I have 2 to the x plus 3 equals 64. What do I do?
64 to 2 power something.
Yeah, so 2 to a power. So I'm trying to get my bases to be the same. So I look, is that 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th? And what do you guys have? This is 2 to the what power? What do you guys get? Yeah, that's 2 to the 6th. Fantastic. Fantastic. So if my bases are the same in chapter 5.3, we said, well, then our exponents must be equal. So set x plus 3 equal to 6 and get rid of those 2's. And then solve, just use subtraction, and we get x equals 3. Okay, so final answer. So I've shown you where your variable is the base. I've shown you where your variable is your exponent. And now here's the last idea. This is where your variable is inside of the log. It's the number, okay? So we set it up. We got our base. Our base is 3. Equals exponent. So again, our exponent is this guy, the 4. So 3 to the 4th is equal to that number, 2x minus 1. So I've converted from logarithmic to exponential. I got rid of that log, so now I can solve. And now I got to solve this guy. How do you solve this thing? Any ideas? How do I solve 3 to the 4th equals 2x minus 1? What do you guys think?
Do 3 to the 4th, make that
81.
81.
Yeah. Looks super scary, but if you just convert that, that's not so bad, right? And now it's just algebra. You guys know how to do linear algebra. You add the 1 over and divide, we get 82 equals 2x. I divide by 2, and I get what, 41? And there we go. Easy peasy lemon squeezy. All right, so I gave it to where the variable is the base. I gave you where the variable is the exponent. And now this is an example where it's that number, okay? Always do the same thing. Convert it from logarithmic to exponential. So we do it one more time. My base is 2. My exponent is 4. And now that's equal to that number, which in this case is 16 to the x. Okay. So now again, we have that exponential where we got to try to get our bases to be the same. Now, the way you do this one is a couple different ways. You can either change 16, or if you know 2 to the 4th is 16, now I got my bases to be the same. This guy's exponent is a 1. That guy's exponent is an x. Bases are the same. Exponents must be equal. So I get 1 equals x, or we prefer x equals 1. Okay. The other thing you could have done, if you had 2 to the 4th equals 16x, you can make 16 2 to the 4th, and then times x is 2 to the 4x. And then 4 equals 4x, divide, and you get x equals 1 that way. You had 2 different ways to solve that one. Okay. Big idea though, if it's logarithmic, get rid of log by converting into exponential. And then from there, you should have, again, 3 different scenarios on how to solve that. Okay, so I've pretty much given you all the different ways that you got that. Okay, guys, we have 2 more examples. We're almost done, and then I'll take questions, and then you'll be able to go. So example 5 and 6 is now when we have an exponential equation. Okay, so when we're dealing with exponentials, the idea is we go back. If I have 2 to the x equal 4, well, we solve that pretty easily by converting 4 to 2 squared, right? And then we learned if our bases are the same, the exponents are equal. Okay. Well, now we run into, well, what do you do when you have 2 to the x equals 3? Well, we can't solve this guy using change a base idea. We can't change 3 to have a base of 2. It doesn't work like that. Okay. But we do know exponent equals log with the base, and then that number that's by itself. We do know that. So we know our exponent is x. We know the base of this guy is 2, so that's the base of the log, and then the number by itself. So now I get x equals the log of 3 base 2. I don't know what that is. It's something probably less than 2. You know, if I plug that in my calculator, okay? But that's the idea, is now we can't use this. We've got to use this guy. Okay? So that's where we're going. All right, so again, we've got a base of e. I can't make e or 24 have the same base. That's impossible. Okay, so then this is where I go. I got my exponent equals log with the same base, and then the number. Okay, so if it's exponential, now we're converting it to logarithmic. So my exponent, my little guy right there, is 2x. I've got log with the same base. The base of this exponential is e 2.718. And then that number all by itself is 24. Okay. Well, this is where we either learned this yesterday or refresh your memory today or learned it today, one of the two. Can't remember with you guys. Log of e. The log of e is a natural log. Okay, that's pretty important. So I'm going to circle that up. I'm going to star it up. I'm going to highlight this. We need to know, especially for my math lab, they're not going to accept log base e. We need to know that this is really a natural log. Okay, so I really have the natural log of 24 equals 2x. Okay, so I usually go from this step, I usually go to that step. I know, oh, I got a base e, I'm going to write natural log. Okay, but for notes, I'm writing it for you guys. Okay, so now the natural log of 24, I don't know what that is. It's some decimal. So if I have 2x equals some decimal and I want to solve for x, I'm just going to divide by 2. Okay. Now, this 24 is on the inside of the log. You can't touch it. So you can't do the natural log of 12 because 24 divided by 2 is 12. You can't do that. You got to leave these two separate. Okay, so when in doubt, do not simplify it. Just leave it like this, the natural log of 24 and then all divided by 2. Okay, this is the exact value. So if my math lab is saying, hey, what's the exact value? That's this guy. If they want the approximate value, we should be able to plug that in our calculator. Okay, this is where I would recommend everybody try this out. Okay, grab your T83 or 84. I'm going to go down to natural log. So I'm going to go down right here next to the 4 and press natural log. And then I have 24. Now, when you press log or natural log, it opens up a parenthesis, and you need to close that parenthesis. So above the 9, close it. And then go ahead and divide by 2 and press enter. And we should get 1.589. If you are not getting 1.589, double check to make sure you have closed your parenthesis. Okay. Also, make sure you're using the right log. So, mistake they might do is, they might do common log of 24 divided by 2, and you'll see it's not quite the same. Okay, so make sure you're not doing that. Okay, so again, it's natural log of 24, close it, divided by 2, I should get this. Other common mistakes people do is they'll go natural log of 24, divide by 2, and they don't close that parenthesis like they should. Okay, well, what your calculator is doing is it's doing the division first, and then it's doing the log. So it's basically doing the natural log of 12, which is what we don't want. We want this guy up here. We want 1.589. So that's wrong too. Okay, so be very careful. Close that parentheses. The big deal, guys. Okay. Anybody having issues? Anybody having questions on how I got 1.589? Give me a thumb. Give me something. What do you got? We're okay with this? It's pretty easy. Okay. Guys, this is the first time you've probably seen logs. All right. This is a topic that is not really discussed in Algebra 2 anymore. It used to be. All right. This is probably for a lot of you guys the first time. If you have seen logs in Algebra 2, then that's because you guys got, above and beyond where you had to in Algebra 2. And this is just an extra topic that they cover maybe at the end of the year. Okay. So if you got there, that's fantastic. But all right, let's finish up number 6 and it'll be time to go. So we got e to the 3x plus 1. Again, I'm doing exponent equals log with the same base. And then the number. My exponent is that 3x plus 1. I have log with a base e. Okay, so I'll write this again, but we need to know that's the natural log. And then the number, which is 38. So I got my exponent, I got my base, and then the number falls into the log. Okay, so I usually go from this step right to here. Okay, and now it's just algebra, right? So I just go ahead and subtract this guy over. I get 3x equals the natural log of 38. Do not subtract 1 from that. Okay, that's inside of log, so that means it's hands off. All right, don't touch it. And then divide by 3. And I get the natural log of 38 minus 1 all over 3. Okay. That's the exact answer. So if my math lab wants exact, and then you should be able to do the approximation. Okay. So in my calculator, this is how I would do this one. I would do the natural log of 38, close that parenthesis, minus, big minus sign 1. And that's my numerator. I'm going to press enter there. And then divide by 3. Okay. So that's our answer. We should get 0.879. Okay. Mistakes that we see, we'll see people do natural log of 38, close it, minus 1, divide by 3. Well, you're dividing the 1 by 3, but you're not dividing the natural log of 38 by 3. So you're not going to get the right answer. People forget to, again, close parentheses. They'll do that, divide by 3. That's not the right answer. Okay. Another way that you could do it, alpha y equals, if you got a T84, number 1, and now this allows you to plug it all in at once. So natural log of 38, close it, -1, and then divide by 3 that way. And you'll get that 0.879. Okay. This is exact, so if MyMathLab wants exact, this is what you're typing in. If they want the approximation rounded to 3 decimal places, that's what this one would be. Okay, you got to see, they might even ask you for both. You got to see what it wants. Okay, this is exact, this is approximation. All right, ladies and gentlemen, if you look at our goals, we've just worked on goal number 1, changing exponential expressions to logarithmic and vice versa, and then we just did the solving logarithmic equations. Okay. Ladies and gentlemen, you have 2 MyMathLabs to be working on. You have 5 for day 1 and 5 for day 2. Okay, so those are due for tomorrow.